Welcome to the Orchid training video on Info Explorer Advanced. My name is Nathalie, and today we'll try and go behind the scenes of some of the Info Explorer sample cubes and show you how to do some more advanced configuration. This assumes that you're familiar with Info Explorer concepts such as cube, view, fact, dimension, drag and drop, drill down, dashboard. For an introduction to Info Explorer and for detailed presentation of Info Explorer right back, please look at other videos. This training will cover security best practices, the different password options, how to remove the lock, performance consideration in terms of refreshing the cubes, using parameters to filter rows, optimizing the queries, including calculations and group by, looking at formulas. Some advanced SQL Query examples, looking at dimension and facts, looking at using union all to display multiple databases and different transaction types in a single cube, looking at non-Sage 300 data as well as optional fields. We will then look at drill down and drill through, standard drill down and custom drill through examples, as well as dynamic reporting, looking at relative dates, filters, some cube advanced formulas, and some dashboard tips. First, let's look at security best practices in Info Explorer. We'll look at the different password options that we have to lock file, the database, and what data within the database. We'll see how to remove the lock and remind you to store a master copy without a password in a safe place on the network, as there is no way to retrieve the password. So let's now look at this in action in Info Explorer. I'm going to open the OE sales item cube, which has been configured with a password. I know the password, so I can open the file and view the data. This file is made up of multiple cubes, sales analysis, by invoice, and OE sales analysis. If I look at the properties on the Home tab, I can see that this file has a password, which is the one we've just seen, to actually open the file. It also has password on the connections, which is the database that this cube is connecting to. For example, you might want some users to run the cube only on the database that's been configured as Orc Ltd, but you don't want them to be able to change the connection to look at another database. In that case, you would lock the connection. We can also add a password on the actual cube. That is the query that is run by Info Explorer when the data is refreshed. So an example of that would be that you don't want users to see the cost in the cube, so you don't include the cost in the query and you lock the cube so that they can't add that field to the actual query. We can also lock the refresh so that users don't refresh too often and or during business hours. And we can also lock the write back and the write back query, which is about updating budget figures and is covered in a separate training video. To remove the lock, you need to know the old password and enter blank as the new password. So a reminder that we do not have a magic way of retrieving the password. Performance considerations with Info Explorer. Info Explorer runs in the memory of the machine where you're running Info Explorer from. The memory capacity of the machine is an important factor in the performance of the cube while you're using it. If you have multiple files open, if you have one file with multiple queries and multiple cubes, you may need a more performant machine. We'll look at the considerations in terms of refreshing the data to make sure that that does not have a negative impact on your transaction databases, and general SQL Server best practices in terms of having the right indexes and rebuilding indexes all have an impact on refreshing the cube. When using the cube in particular, you need to make sure your query is optimized, that you only return the row that you require and the columns that you require. And for that, you can use group by, filter, and parameters, and add the calculations in the query where possible. You can also turn auto-calculate off while you're dragging dimensions around. So we'll look at all this in a bit of detail now in Info Explorer. So Info Explorer opens all your files in the memory of your machine where it's run. So in this case, we have multiple CUBX files open here in the tab at the top. Got 5. And each of these cube files may have multiple cubes. Here I've got my AP cash flow and my cash flow in one single cube so that I can add information from both in a single dashboard. So should you have multiple cube files or multiple cubes within a file? There is no single answer to this, but some of the elements to take into consideration include the advantage of having only a smaller number of cubes to manage, email, schedule is a good option if the same people are using all the information, and you can add content from the various queries into a single dashboard. The main disadvantage is that the one single file can get too large and a little bit confusing. So generally you'd have a mix of both. You'd have a few CUBX files, which you may open all at the same time, like I'm doing now, and some of these files may have multiple queries. In terms of refreshing, when I'm looking at a cube, I can choose if I have multiple queries within the cube, I can refresh them all at the same time or one separately from the other. As we've seen before, you can have a password on the refresh to make sure that only users who know the password refresh the data, which will limit the number of people who refresh. And if you have large cubes that may take a little bit of time to refresh, you might consider looking at Process Scheduler Level 1 to schedule that refresh after hours. And if you have a password, you can pass the password from Process Scheduler. The time it takes to refresh will obviously depend on the machine and on your SQL Server and the general performance of your SQL Server. So we'd consider you make sure that your SQL indexing and your jobs to rebuild indexes follow the general best practices of database administration. There is an option here in Properties to auto-refresh every X minutes. So if you have a cube that's always open and you want to monitor the new transactions as they're coming in, you might want to set that to refresh every 15 or 60 minutes, depending on your requirement. And in such a scenario, you'd want to make sure that the query is as small as possible. In any case, you want to make sure that your query is optimized, which means you're only returning the rows and your columns that you require for your analysis. So let's look at this in a bit more detail now. So now let's look at an order entry, sales history, cube query in details and the performance consideration in that query. So I'm going to build a new cube from OE SHDT from scratch, using the same connection that I've already got to Orc Ltd, and finding my OE SHDT table. There it is. I want to show the customer name. Let me add the AR cast table as well. Join customer to the ID cast, as you'd do in a typical Crystal report, sales analysis type of report. The query gets built up at the bottom there, select star from those two tables. That means I would have all the fields from the AR cast table, and most of them I don't want to use in my analysis. So all I really want from my customer table is the customer name, so I'm going to show that. And then for my order sales history, I want customer, item, year, period, transaction date, transaction number, location, category, quantity, cost of sales, amount sales, and sales return. If I go to data here, I can see what I've got. That sounds good. So I go OK, and my cube gets created here within the file that I was looking at. So I can rename this one and start dragging. As you can see, I've brought in the customer name and the customer number separately. So that means that if I want a view by customer and show the customer number and the name, I need to drag to column there. So the main advantage of doing this is that you can then sort by customer name, put the customer name before the customer number. However, it means that you have two things to drag, and it creates two dimensions, so the cube is a little bit larger. So you'll notice that in our sample cubes, we generally bring back the customer name and the customer number together, the item code and the item description together in one dimension, one field. You'll also notice here that the Info Explorer, when connecting to Sage 300, uses the Sage Data Dictionary to give you some friendly names of the field names in Sage 300. Because I'm going to be dragging a few fields into this view, I might want to turn auto-calculate off. So in this case, you see it's not gold, it's not enabled, so auto-calculate is turned off. So if I drag field here and I want to add my quantity and my sales amount and let's say my cost of sales, the cube doesn't refresh and recalculate immediately. I can click calculate now to refresh. Once I've got a view that I like, I can turn on auto calculate again. So now it's sort of orangey gold, which means that auto calculate is on. So as I'm adding a new field here, it should calculate automatically. So let's tidy up this query a little bit. Go into Query Builder. I'm going to copy this into SQL Query Analyzer, or SQL Management Studio rather, I should say, and work on my query here. First thing I want to do is add one fact, one field that will calculate the net sales. These type of calculations are good to do in the query because they will be done for every row and they also need to be done for the total. It is the same calculation for each individual row and for each individual total, regardless of how I'm looking at the data. If you add them to the query, it is going to be performing better than if you create these same formulas in the cube. When you add a field to the query, you need to make sure that each column that this query is returning has a unique name. So if we run this query, let's copy this back into our Query Builder. Refresh this cube. And I'm getting this error that this query must have, that all columns returned by the query must have a name. So I need to add the name to that second field in there. So now when I refresh the data, I can see two new fields have arrived, net sales and margin. We've said that wherever possible, add the calculated fields in the SQL query. However, there are some instances where the field needs to be added in the cube, and Info Explorer gives you that capability. For example, margin percent. Click on Edit Fields, and we create a new fact, which is going to be called margin percent. The caption can have the percentage sign, but the field name should not have a blank and no non-literal characters. It's going to be a fact, and it's going to be defined as a formula. We'll look at some of the other options a bit later in this training. The formula for margin percent is the margin divided by the net sales. Because we don't want to have a division by 0, we need to add that. So net sales dot value equals 0, make it 0, else make it margin dot value. So the dimension, the factor name, margin dot value, to get the actual value for the row column combination we are looking at, divided by net sales dot value. The totals are going to be evaluated, so this formula will apply to the total. So the total isn't going to be a sum of the values that is being shown. So we save that, close, and now my margin percent is showing here. One thing I forgot to do, I need to multiply by 100, as the tip in the example was telling us. So now I've got my margin percent, which is calculated for each customer and year combination, calculate for the total, and overall for 2019 it's 59%, 62% in 2020, and on average for the 2 years was 61.18. If I add the item category in front of this, the margin percent will be recalculated for each category combination. And if I want to see that even more clearly, I would say show row totals in the display tab. Now I can see my margin percent being 59% for A1, 46% for A2, etc. So first tip when building the query, only return the columns that you need, and if you can, do the calculations in the query. So this is what we've done here. As you can see in this table, there are 172 rows because I'm showing each transaction detailed. So this is quite a detailed sales history cube. We generally suggest that when you do that, you only do that for your current year or maybe the last 2 years. But if you want a cube that has the last 10 years of history, you sort of group by item, year, and period. So let's look at how we would do that in here. When I group by customer, item, year, period, location, and category, and refresh this query, I've only got 133 rows. So way few rows, and in a really large data set, that would make a big impact. When you group by, as you probably know, you need to make sure that the fields that you're looking at are aggregated. So generally for a number, you would use sum, but you could also use average or min or max, depending on what you're trying to calculate. So now I can copy this into Query Builder. I have removed a field from the query, so the field gets removed from the cube. And you'll notice too that I have now brought back my customer number and customer name in one single dimension. The other way we can filter the number of rows that we return beyond the group by is by using a where clause in SQL. So I want to return only the transactions which are greater than a certain year. So where the year is greater than 2019 rather. So now, if I refresh, I'll only have 2020. So here, we've hard-coded the start year, but we have the capacity in Info Explorer to use a parameter for the start year. So here it's been configured. A parameter is called start year. It's got a default value of 2016, and it's not hidden, which means the user will be prompted when refreshing. So to do that, I'm going to replace my hard-coded parameter in the query with % followed by the parameter, followed by % again. If I now refresh this cube, I'm going to be prompted for a parameter. I'll leave that as 2016 for now. So I've got more years that are coming through. Occasionally, when you click on the query builder, you get an error like this along the line of invalid SQL statement. This is because Query Builder cannot deal with some of the SQL command. For example, if you have a parameter with a percentage or some cast function in SQL Server. This does not mean that your SQL statement is actually invalid. So if you get this error, it means that you have to use SQL Management Studio and go to the Properties, Cube, and update your query through here. Now we're going to look at some advanced SQL query tips that are useful in Info Explorer analysis. Facts and dimensions. In some cases, you might want a numeric column to become a dimension, something you can do your analysis by, and a string column you might want to convert in the query so that you can use it as a fact. For example, optional fields are always stored as a string in the database. We're going to look at how to use the union all SQL query statement to show data from multiple databases, add different types of transactions. We're also going to look at non-Sage 300 data and look at tips around collation and how the connection is passed from the cube to the query. We're going to look at some other SQL queries that are useful for analysis. For example, how to deal with optional fields, using the case statement, using SQL views and SQL stored procedures to do some data manipulation, and finally look at using Orchid data views. Let's now discuss dimension and facts in the query and in the cube. When you run a query and Info Explorer refreshes that query, any string column in the query becomes a dimension in the cube, and any numeric columns in the query becomes a fact. So for example, net sales, which is a number in the query, becomes a fact that I can add up and work with in the cube. That's all fine. Customer number, it's a string in the query, it becomes a dimension. That's all fine. In some cases, you might want a numeric column in the query to become a dimension. For example, fiscal period in this order entry query. In this case, you have two ways that you can do that. If you can't amend your query, you can edit the fields and choose your period fact and switch it over from fact to dimension. Save, close. Now the period is not blue anymore, and I can drag it along as a column underneath my year. Another way to deal with this would be to convert the numeric value in the query to a string using cast or convert. The advantage of switching it in the query is that if you use the same query in another cube, for example, you've already got it converted in the query, so Info Explorer will make it into a dimension without you having to change anything in the cube. Conversely, some dimensions, i.e. string columns, you might want them to be a fact. A typical example in Sage 300 world is that optional fields are always stored as strings in the Sage 300 database, and the optional field type tells Sage whether to display the field as a string, a date, or number, or etc. But Info Explorer only sees the database field type, which is a string. So in this instance, if you want the string to be a fact, you will need to convert the string to a number in the SQL query. So if we look at the example optional field on invoices called max order, it's in sample data, it's a number stored as a string, so we would use the convert function in SQL to turn it into a number. When you want to use Info Explorer to show data from multiple databases, you can use the union all command in SQL Query. For example, in the GL consolidated details cube, GL account summary across two databases. So we're going to look at that and see how we can use that and update it for other databases than SAM Inc. and SAM Limited. So if we look at it here, we can see two columns, one for SAM Inc. and one for SAM Limited. Looking at the query builder, we can see we've got one query here which has some fields selected. And the first part of that expression is just a text that says SAM Inc. because we know that this part of the query is going to be linked to SAM Inc. And if we look at the next one, it's going to be linked to SAM Ltd. A few things to note: when you use union all, you need to have the same number of columns in each component of the union. So if you're selecting 5 fields from SAM Inc., you need to select 5 fields from SAM Ltd as well. The collation should be the same in both databases. The names that are going to be read in the cube will come from the first part of the query. So let's look at this one in Query Analyzer. So we've got union all here. Just to highlight what I mean by the first part of the query is this is what I call the first part, union all, and then the second part. So the first one, we've said SAM Inc., which is just the text. Select a bunch of fields from a bunch of GL tables. You notice that we just have the table name here. We don't have the database name. Because it's the first part of my union query, the connection details that I use in Info Explorer will be passed to any tables that are in here and that don't have the database name in the front. Then the second part of the query, as you can see, it says SAM Ltd as a text, and then in my from, I've got the full database name, .dbo, my schema, .my table name. These tables that have the database and the schema will not be replaced by the connection details from Info Explorer. So if I want to use another database in here, I need to change it here. So for example, Orc Ltd. I need to change all of them. So I can use search and replace or double check and manually update them. If I want to add a third table, I would copy the query, replace the database name Orc Ltd with Orc IN2, and then add another union all. Let's actually do that quickly. I would copy all this, paste, and this one would then become Orc IN2, and here I replace them all. So I can take this and find my query here, paste the new one, click OK. And now I've got 3 databases all going to Sam Inc. and Sam Ltd. We can also use Union All to add up different types of transactions. For example, in this IC stock quantity analysis, we have information from ICI lock for the quantity on hand, quantity on purchase order from the PO module, and quantity on sales order from the order entry module. So the way we've achieved that is, again, using Union. So the first one part of the Union looks at IC, ICI log, IC item, etc. Next one, look at purchase orders. And the third one looks at order entry and looks at outstanding orders. So if I look at this query in Query Analyzer, some of the important things I can notice is, because I need the same number of columns in each components of the query, I've got my quantity on hand, which is set to the value from the table when I'm in the IC part of the query, and then I set the quantity on purchase order and the quantity on sales order to 0. However, when I'm now looking at the outstanding purchase orders, I'm setting the quantity on hand as 0 in that part of the query so that we don't double things up, and I'm adding my quantity on purchase order, my outstanding purchase orders, to the field quantity of PO. It's still 0 for the quantity on sales order for the data that's coming from the Union All. So the Union Alls will basically add the rows. So you might have, if you have 20 items with stock, you can have 20 rows from the first part of the query. Then when I'm looking at the POs, I'm going to have a row for each item location combination that has stock on purchase order. And I'm looking at the final thing, I'm going to have a row for each item location combination that has some outstanding sales orders. So I'm seeing 0 for stock on hand, 0 for quantity on purchase order, and the back order quantity times the conversion unit will give me my quantity on sales order. My expected ship date is going to be today because I've got it now. For my quantity on PO, the date will come from the expected ship date of the PO line, and my quantity on sales order, the date will come from the expected ship date of the line. So this is really to give you ideas as to what we can do with Union. So you can use SQL statements, Union All or case statements in the query to do some data manipulation, but in some cases you may have a lot of data manipulation to do before you can display the information in a cube in a nice and simple way. For example, if we look at the sample IC stock aging cube, we can see in the properties of that cube that it is running this SQL statement to get the data, and that SQL statement is executing a stored procedure that assumes that the stored procedure exists in the database that we're connecting to, and the stored procedure will in many cases create a temporary table and populate the data the way we want it in the temporary table. So we won't go into the detail of how that works in this particular example. In this case, we're doing calculation of the aging buckets of our stock aging. So you can see the stored procedure exists in the Orc Ltd database, and among others, it creates a temporary table. Similarly, I can use a SQL view as a source of the query in Info Explorer to simplify what I see in the cube and also to allow reuse across different cubes. A typical example is with optional field in conjunction with Orchid data views that simplifies the creation of the view and lets you store the script of the view in Sage 300 so that when you dump and load or move to another server, you have your view script within Sage 300. For example, here I've got a cube that's showing amount due by vendor with 1 column per optional field so that I can do my analysis by optional field. So behind that, we've got Sage 300 data view with the view script, and as you can see, there's one column for each optional field defined for the vendor, and I can create the view into SQL directly from here. So data view can be also used to store any stored procedure or view that will not dump and load, but that is used in reports. Okay, so Info Explorer can be used on Sage 300 data, but it can also be used on non-Sage 300 data, for example, CRM or other SQL or DBC databases. We're going to look at an example using Sage CRM, because a lot of you probably have access to Sage CRM, and we're going to look at two sides to that cube. Here I've just got a very simple cube on companies out of CRM. So let's look at what's behind that. I go to my properties, my connection. I've got a connection to my CRM database. And if I look at the query that's behind that, it's very simply select the company details from the CRM database. And then I can do everything that I can do in the cube, drag and drop. Now, a more useful part of that would be to use Info Explorer to consolidate information coming from Sage 300 as well as information coming from CRM. So to do that, we can do it again sort of two different ways. One is we can build this query here using a union. So the top part will show details from CRM, so opportunities with the forecast of the opportunity and the expected close date of this opportunity. And in the bottom, I'm looking at my sales history for that customer by year and period. So in this case, you will notice that the first part of my query is looking at that CRM database. I've got opportunity here. The second part is looking at Org Ltd. So when this data is refreshed from Info Explorer, the connection details will be passed to that table. They'll be the ones they're assuming that my connection details are to the CRM database. And then I'm hard coding the Sage 300 database I want to look at. So this would be useful if, for example, you have one CRM install and multiple Sage 300 databases that all go to the same CRM. The other flip side of that is, if I look at this query, I'm going to set my cube to connect to Sage 300. So I'm not putting the whole database name here in front of ESHDT. And then I'm unioning that to opportunity coming from the CRM databases. So if it is on a different SQL server, you also have to put in, you have to link the two servers, and you have to put the linked server name in that query as well. I've got one amount here that I'm showing that's already adding the forecast and the net sales in the query. So I only add one amount in here. So where that would be useful is if you just want to manage that one amount and see how it's spread across the month. So I'm seeing I've got sales, September and December. I've actually got a whole lot of big sales coming through for prospects, so people that aren't a customer. And then I've got a big sale forecast for December for Mr. Ronald Black. So this lets me project my sales and compare it to my actual sales. In Info Explorer, you can drill down to view detail of the data you're showing, and you can also drill through to Sage 300 screens. So drill down applies to both Sage 300 and non-Sage 300 data. Drill through is to open a Sage 300 screens. We'll look at standard drill through, how to amend some of the drill through options, and how to create a new custom drill through. Okay, so drill down, just select a field, right click, choose drill down. It will show you the list of what this total is made up of, and you can go Control C to copy all that to clipboard, put it in Excel, manipulate it sort of on the fly without having to export the whole thing. This drill down applies to Sage 300 data as well as non-Sage 300 data. Drill through, on the other hand, is designed to open the underlying Sage 300 screen. So in my cash flow cube, for example, which has AP outstanding transactions, AR outstanding transactions, a dashboard that shows me a bit of both in the single page. If I look at my age outstanding transaction, my AP cash flow, I'll select an amount. I want to find out what this is all about. This is a really large amount. I want to know what this is all about. I can right click and say drill through to, in this case I've got the choice to drill through between two things. Because I'm showing vendor and documents by vendor, I can drill through straight to that AP invoice or to the AP vendor activity screen. So let me open the AP vendor activity screen first. Because I haven't connected yet, I need to enter my password to open my Sage 300 session, and it opens the vendor activity for vendor 1400. I choose the other option, which is drill through to the AP invoice. It will open that invoice entry screen. Now, how does that work? If I look at edit fields and I choose my vendor, I can see that the drill down has been configured to automatic. Now, automatic means that Info Explorer knows. We've told Info Explorer that if a field is called vendor, go to the vendor activity screen. And in the background, it's doing this. It's opening this roto ID. It's passing the value that I've got for the vendor field, and this is the description that I'm seeing when I right click. So if we look at drill down from a PO, look at the field setup for that, we can see that it says inquiry mode equals 1. So that means when I drill through to the PO, it's coming up like this without a post button, without the ability to add a new PO, regardless of my security right. If I wanted to change this, I could change this to say inquiry mode equals 0, in which case when I drill through to my PO, the screen will come up like this. Now let's look at how to configure a custom drill down, and we're going to do that on an extender table that you may have seen in another presentation called NPS Customer. So if I look at my properties, table query is pretty simple. I'm just selecting from the NPS Cust table, which showed the Net Promoter Score by customer, and joining that to the customer table. If I look at the fields that I've got there, the customer, I set that to automatic, and I can drill through to the customer, or I could set it to go to customer activity or customer number. I'm going to make customer number. And then my NPS reason, I'm going to say I want to open that custom extended table when I look at this. So I'm going to choose drill down is custom, put the roto ID of the screen that I want to open. For an extended custom table, it is VI 1007. And because the custom table editor in Extender is calling a script called VI 1010, then I'm passing the script name and I'm passing my key values. In that table, the key values are NPS Cust. So it's going to be key 1 is the customer ID that I'm looking at, and that table has a second key field, which is the date. So key 2 is date. So if I right click on this and say drill through to NPS score, it opens that custom extended table for me. Finally, let's explore dynamic reporting in Info Explorer cubes and dashboards, which is one of the most powerful functionality of Info Explorer. We'll look at doing some date manipulation and some relative date filters using getDate and convert in SQL. We'll look at some formulas that exist only in the cube, like percent of a column, percent of a row, percent variation across, ranking dimensions like customers and vendors, and doing top 10 type of examples. And then we'll explore dashboard functionality like adding view from separate cubes, filtering, and playing with the dashboard sizes. So while there is no relative date functionality in Info Explorer, you can use some SQL date functions to return some things like, for example, in this cube, we've got two things. Cell week gives us the week number the transaction took place in, and that's looking at the date part function. And current month is also using a case statement that says if the transaction is in the current month, set to current month, otherwise make it in other months. So if I filter, I can then show, okay, which week are in my current month, and I'm seeing that, or I turn that off, select everything again, and I'll have all my data. How did that work? Look at that in properties. In the query here, you can see, actually let's look at that in Query Analyzer. Okay, so if I look at the query, I can see, firstly, we've got the useful function here to convert a sage date into an actual date in SQL. So make it into a string and then convert. And once we've got the SQL date, we can use SQL date functions like month, year, etc. So here I'm using a case statement to compare the month of my transaction to the current month. And then in this other part, I'm using the date part function to get my week cell. Now let's look at using some Info Explorer cube formulas to display some calculations that have to be done within the cube because they're relative to what I'm looking at. So in this example, I'm looking at net sales by customer and year, and I would like to know what is the percentage change across the year. So my year I set up as my columns. To do that, I need to create a new fact, which I'm going to call percent variation on year. So it's a fact, it's based on net sales, and I'm going to display this as a percent variation across. So across mean I'm going to compare the value in my different columns. So if we look at this, 2019, 2020, that's going across. And I want to save this and I want to apply some styles to this so that I can see I've got styles set up already in this cube. Decrease with a red background color, increase with a green background color. And I'm going to apply that to this field. So if the amount is greater than 0, make it a decrease. Save. And create a new rule. If the amount is greater than 0, apply the style called increase. That was wrong. Less than 0, decrease. So close this, save. Now I'm seeing that Customer Bargain Mart has increased by 42% between 2019 and 2020, but Ronald Black has decreased by 31%, and the negative ones are highlighted in red. Now, if I drag my category here, the percentage will be recalculated per customer per category. So somebody that had in that category that there were sales in 2019, nothing in 2020, so it's decreased by 100%. And I'm seeing overall I've got an increase of 91%. So now let's look at our cash flow cube, and I'll see here amount due by customer and by year. What I want to know is how much each of these customer owes me as a total of what's owed. To do this in Info Explorer, I need to add a field which is going to be called percent of the total. It's a fact, it's based on the sum of the amount due, and it's going to be displayed as a percent of that column. So in the view that we are looking at now, we're seeing customers with a grand total. So when I add this field as percent of column, it will show me 100% for the grand total for all customers, and then each customer percentage is shown here in that column. I can then right-click on that field and choose Sort Customer Number by this column to sort by the value due in 2019, or I could rank sort by 2020, or I can sort by the total amount. And if I want to sort in descending order, I can click on here and I'll see that breakaway design represents 40% of the total, but only 19% of the total due in 2020 and 41% of the total due in 2019. If I use my pre-filter here to look only at the retail customer group, I'll see that the percentages are recalculated based on what I'm displaying in the view that I'm looking at the moment. I can see percent of the total, but I might also want to add a rank so that I can select my top 3, top 5, top 10 customers. To do this, I need to add a field, a formula of type rank. We've already added one here. Customer rank is a fact, and it's set as a descending rank, which means the one with the greatest amount due will be number 1, the one with the smallest will be the last one. And ascending rank is the opposite. So it's ranking based on the amount due, and I can apply styles to display different ranges in different colors, bold or italic as required. This customer rank field, let's add it here. Now I can see that it's ranked based on the total. If I just want to see the top 5 of my customers, I could come here, select that little grand total filter, but I might, because I've got multiple years in my views, I could say, show me all customers that were in the top 5 by amount due in 2019 or in 2020 or in any of the years. So let's select any one year where the customer rank is in the top 5, so less than or equal to 5. So I can see here that I've actually got 7 customers that have been in the top 5 in either 2019 or 2020. Now I can change that to say grand total. So it's going to show me the top 5 by amount due across both years. Now this was looking at all my customers, but if I apply a filter by customer group, like I have set up here, the filter will apply and the ranking will get recalculated. Finally, let's look at how we can put all this together in the dashboard. Info Explorer dashboards can include any views or charts from any of the cubes that are part of that file. So in this cash flow cubes, we've got a dashboard here which shows lists and graphs for the AP cash flow. We've also got one that shows us details from AP and AR. So what I'm going to do is add another dashboard. So you can have multiple dashboards. Create a new one here, and I can add anything from here. I'm going to add you notice that this view had a pre-filter. The pre-filter has come on the dashboard, and maybe my ranked outstanding by vendor. I can change the size, and maybe I want the customer one to be over 2 rows, and I want my vendor to be 2 rows and 2 columns. And I can also add, I can also add a chart here by vendor. If I want to do something different, I wanted to add the customer chart at the top and the vendor chart next to it. So we've noticed that the pre-filter has come through from the view. The vendor dashboard doesn't have a pre-filter. I can still add one by saying edit the pre-filter and choose, for example, I'm going to say with a vendor group equals inventory. And I can use the functionality to toggle the pre-filter on and off. I also have access to, adding, if I want to change what I see, I can show the available fields, the displayed fields, column heading or row heading. So here I've got customer number. I have access to the little filter that we looked at before on the grand total or the different years. So we have looked at security best practice and how to control what users can see and do in Info Explorer, discussed performance considerations, looked at some advanced SQL query tips to optimize what and how you can analyze with Info Explorer. We've also looked at the ability to drill through to say 300 screens and explored formulas and calculations that are refreshed dynamically when we change the rows and columns we view in a cube. Finally, we shared some dashboard tips. We hope that this training session helps you configure Info Explorer to analyze key drivers of the business in a user-friendly and powerful manner. Thank you for your time. For more information, go to our website www.orchid.systems and look for Info Explorer.